Okay, good afternoon, good morning, good evening, whenever you happen to be watching this. This is going to finish up Unit 7.5, which was Properties of Log Functions. So in class, we talked about some of the properties, and remember that logs are exponents, so they follow the same basic properties as exponents do. We can expand and condense logs using those properties of exponents. If you have an argument where the log has things being multiplied together within the argument, you can split it up into two separate logs through addition. If you have an argument where you have division within your argument, then you can split it up through subtraction. And if you have a power raised to your argument, your argument raised to a power, then you can bring that power out to the front of the log and basically multiply it by the log. And then you can go backwards, and we can condense that way, and we've done a couple of examples. We also solved a couple of equations where you have to change a log into an exponential or vice versa in order to actually solve the problem. And that's pretty good as long as there's a base that we can actually deal with. The problem comes in is, what if we don't have a base that we can actually do something with? So my first example here is going to be, what if I have the log base 5 of 89? Well, if you remember from class, that is basically asking 5 to what power will give me 89? 89 cannot be written as a nice, easy base of 5. 89 is not a power of 5. 5 squared is 25. 5 cubed is 125. So this is going to be someplace in between 2 and 3. That's pretty much all I know right now. There is something which is called a change of base formula, which we can utilize here. It is called the change of base formula. And this is really kind of nice because what it allows you to do is it allows you to change the base of any logarithmic function into a common base of some kind. Technically, it could be any base you want it to be. It could be a common base of 10, it could be a natural log base of e, or it could be anything else, and it's going to work. So what the change of base formula says, it says that if I take the log base a of m, that can be rewritten as the log of m divided by the log of a. Notice that in the denominator, it's now taking the log of a. That base in the original log actually becomes the argument of the denominator's log. Notice that I also did not write a base on either one of the two of those, log m and log a. I did not write a base. If we don't write a base, it's assumed to be 10. But it doesn't matter. This is the same thing as the log of m base, 7, over the log of a base 7. It doesn't make any difference. That's the really nice thing about this change of base formula. Doesn't matter what we put the base as. I could also just write it as the natural log of m over the natural log of a. Remember that the natural logs are bases of e. What it does is it allows us to change the base into a common base. Does not make any difference what it is. So if you have your calculators, we can actually test this out. I don't have a way to pull up my calculator anymore on here to be able to show you. But if you have your calculator, we're going to try this, or I'll let you guys try it out. So if I want to evaluate the log of a log of 89 base 5, we're going to rewrite it as the log of 89 divided by the log of 5. And you can actually type that into your calculator. You can actually type in log 89, make sure you end the parentheses after the 89, and then divide it by log of 5, and it's going to give you some kind of a decimal approximation. What I want you to try is then I want you to also try typing in the natural log of 89 divided by the natural log of 5, and it's going to give you exactly the same decimal. And if you have the TI-84, you can actually do the log base that I think we showed in class. You would go to math and then scroll down, I believe, and it would say log base. You can input any base you want, so you can actually test log of 89 base 5 and see that it's going to give you exactly the same thing. And I believe that the decimal approximation here works out to be about 2.7889, and that's rounding a little bit at the end. But that's what it would be. So this is what is called the change of base formula. The way I always remember the change of base was that the number down here in the bottom, the base, is the bottom log. The number that we are taking the actual argument of is the top log. Again, base, bottom. That's just the way I remember how to do it. So the one that's down on the bottom, the 5 there, is the one that ends up as the bottom or the denominator's log. Hopefully that will help. Anyway, change of base formula is pretty cool because it allows you to evaluate in even just, I mean, your iPhones can do this, or whatever phones you have most likely can do these kind of things if you do use the change of base, because most of the phones nowadays can do logs. I think you might have to turn it to the side or something like that. But anyway, don't want to waste too much time on that. So we'll try one more. We'll do the log of the square root of 5 base square root of 2. Again, this is not something that is super easy to figure out. I am going to rewrite it using the change of base formula, which says that'll be the log of the square root of 5 divided by the log of the square root of 2. Now, we do have to remember that the square root of 5, square root of 2, both of those things are actually exponents of 1/2. So that can be rewritten as the log of 5 to the 1/2 power divided by the log of 2 to the 1/2 power. Because remember that square roots are powers. I'm going to erase this orange thing over here so I can write. Remember what we can do now with the exponents is we can bring those out to the front. So this now becomes 1/2 the log of 5 divided by 1/2 the log of 2. Of course, the 1/2s now can actually cancel themselves out. Divide those away. And we are simply left with the log of 5 divided by the log of 2. And again, you can type that in straight into your calculator. Log 5 divided by log 2. ln 5 divided by ln 2. It's all going to work out to be the same thing. Let me see. I think, yeah, I worked this one out to be 2.3219. All right, the most important part about this is you understand how the formula works, not necessarily that you can plug it into your calculator, but that the formula does actually work, and it's going to give you the same result no matter what the base is you change it. It's called a change of base formula. All right, so that one pretty much wraps up Unit 7.5. I'm going to do hopefully what should be a short video for each one of the sections. This will probably be the shortest of all the videos. So this will be several sections for you to finish up for your lesson for Tuesday.